Hello everyone, I am Marshit from Sri Venkateshwara College of Engineering. Today I am here to discuss about the topic structure and union, stacks, queues and linked lists. So first we will see about structure and union. Structures and unions are used in C programming to define a new data type. A structure can hold different data types, which a union can hold only one data type at a time. These are essential for organizing and managing complex data effectively. So here is the example of structure and union. Here the structure employee is created and the data type character is used for creating name of a size of an array 20. Integer data type is used for creating ID and here semicolon is used at the end of the structure. Union is also the same as structure. Here only the syntax union is used instead of struct. And in this picture you can see clearly the structure and union example. In structure, the syntax struct is used, whereas in the union, the syntax union is used. Here the same, the data type integer and float and character is used. So the next one is stack, where push and pop method is discussed in this. A stack is a data structure that follows the last in first out, that is LIFO principle. Push is used to add an element. Pop is used to remove the top element. It's commonly used in programming for expression, evaluation, and passing algorithms. Here is the example of stack where push and pop is used. So here you can see the inserting and deleting elements in a stack. In a stack, when you push A, the element A is added into it. When you push B, the element B will be added, and here B will be the topmost element. When you push C, the element C will be added and C becomes the top element. When you push D, D will be the top element and D becomes now the top element. When you push E, E will become the top element. And here when you use pop, the last element which is entered will be popped out, means the element E will be removed from the stack. Like this, push and pop method is used in stack operation for inserting and deleting elements. So the next concept is queue, where insert and delete method is involved. A queue is a data structure that follows the first in first out, whereas in the last slide we saw stack uses last in first out principle. In queue, elements are inserted from the rear end and removed from the front end. It's widely used in process scheduling and network packet handling. So here you can see this is the rear end and this is the front end in the queue. Here is the example of queue of inserting and deleting an element. Here the elements are added from the rear end. When you enqueue A, the element A is added. When you enqueue B, element B is added from the rear end. When you enqueue C, element C will be added. When you enqueue D, element D will be added from the rear end. But when you dequeue here, the element A will be removed from the queue, which is the first in first out principle. Whereas in stack, last in first out will be followed, but in queue, the first in will be the first out. Here this is the last concept but not the least, linked list. Insert and delete method is used. A linked list is a linear data structure where elements are linked using pointers. Insertion and deletion can be efficiently performed anywhere in the list. It's frequently used in dynamic memory allocation and adjacency list for graphs. Linked list or one-way list is a linear collection of data elements called nodes, where the linear order is given by means of pointers. Each node is divided into two parts. One is information part and another is address part. The first part contains the information of element and the second part contains the address of the next node in the list. Here is the example of linked list where insert and delete method is used. Here this first part contains the information. This is 5 is the information part And the second part, this contains the address of the next node in the list. This 2000 is the address of the next node in the list. So here you can see the address of the next node. First star head contains the address of first node, and here you can see the syntax for using inserting and deleting. This is for insert and this is for delete. So this is the end of this slide.